Applications for radio frequency energy harvesting include wireless sensor networks, wearable technology, wireless charging, and IoT, that is Internet of Things. So, talking about the history of radio frequency harvesting systems, in 1954, Arthur C. Clarke published a paper entitled Extraterrestrial Relays: Can Rocket Station Gives Worldwide Radio Coverage? In this paper, Clarke proposed using satellites to relay radio signals around the globe. He also suggested that these satellites could be powered by solar panels or by beaming radio frequency energy from the Earth. And in 1960, Peter Glaser proposed using large antenna to collect solar radiation and convert it into electrical energy that could beam down to Earth. So this concept is known as power beaming. And in 2001, John Perkins patented a method for harvesting radio frequency energy from ambient sources such as television or radio signal. So coming to the components, the main two key components of radio frequency energy harvesting system is the antenna and a rectifier circuit. The antenna is mainly used to capture the radio frequency waves and convert them into an AC voltage source. And the second component, that is a rectifier circuit, is used to convert AC voltage sources into a DC voltage to keep the power to the destined devices. So now moving forward, the types of radio frequency energy harvesting systems. Actually, so the main two types are dedicated radio frequency harvesting systems and ambient radio frequency harvesting systems. So in dedicated, we have the dedicated radio frequency sources. The radio frequency energy is not free. A cost of constructing the sources to be specifically provide the energy is used and incurred. They are fully controllable and therefore suitable for devices with quality of services constraints. It is also a predictable energy supplier, and they also provide high power densities. But in the case of ambient radio frequency harvesting systems, as the name suggests, they are ambient radio frequency sources. These sources are not solely dedicated to provide radio frequency energy transfer. It is essentially free and it also uses already constructed radio frequency sources. It is not controllable and also not a predictable energy supplier, and also provide fewer power densities. So the next topic is basically how does radio frequency energy harvesting system work? So the antenna is used to collect radio frequency waves in the surrounding area. The matching circuits make sure that the greatest amount of power is transferred from the antenna to the rectifier circuit, as the incident radio frequency power is then converted into DC power by the rectifier circuit. So the energy storage devices can also serve as a backup power source for when times the external energy is not accessible. So here are the main four types that we come across. There's the circuit, that is the antenna, the impedance matching circuit, rectifier circuit and storage unit, and a voltage multiplier. So this is a basic circuit diagram with all the four parts that we mentioned earlier. So an antenna is a radio frequency signal transducer that transforms radio frequency signals into AC voltage. An antenna with a small footprint and a strong antenna gain characterizes an effective radio frequency energy harvester. The moving forward to impedance matching circuit. A resonator circuit called an impedance matching circuit operates at a specific frequency to maximize the amount of power that is transferred from the antenna to the load. So transmission losses are decreased and the maximum amount of power can be transferred from the source to the load in a radio frequency energy harvesting circuit or any other AC circuits when the load impedance and the source impedances are equal. So as the name suggests, the impedance matching circuit's goal is to make the load impedance look like the complex conjugate of the source in order to transfer the most possible power to the load. So the impedance matching circuit makes the impedances match at a specific frequency because the reactances are frequency dependent when they match. So the reactances cancel out or the resonances occurs and maximum power is delivered. So moving on to the rectifier circuit and storage unit. So using a rectifier circuit and storage unit, direct current is converted from alternating current. So due to the fact that it straightens the current's direction, this procedure is known as rectification. A diode serves as a circuit's central element. A semiconductor device known as a diode only permits current to flow in one direction. Rectification can be accomplished using a variety of circuit types, including bridge rectifiers, voltage multipliers, and rectifiers. So as we already mentioned, the rectifier combines an antenna and a diode. So due to the quick switching times, the silicon Schottky barrier diodes are the most widely utilized diode for the antenna. And because radio frequency energy harvesting system circuit works at high frequency, it is necessary to match them with the diodes that have quick switching times. So moving on to the voltage multiplier. A voltage multiplier or a double circuit is a special type of rectifier circuit consisting of a network of capacitors and diodes grouped into N stages. It provides radio frequency or DC conversion, and secondly, it also amplifies or boosts the DC voltage according to the number of stages in the doubler circuit. The storage unit is a storage capacitor that also acts as an energy reserve. Moving on to the applications of radio frequency energy harvesting technology. So powering low power autonomous sensor in sensor networks. Wireless sensor networks, WSNs, are a network of interconnected nodes and sensors that may interact wirelessly and gather information about their surroundings. So mainly the network's sensors gather data, it processes it, and then wirelessly transfer it to the base station. So the sensors are able to operate without power line hookups or battery replacement thanks to the radio frequency energy harvesting technology. So by using this technique, the sensors may generate their own electricity by collecting radio frequency energy from their surroundings. So this basically results in a significant decrease in the price of routine battery replacement. And additionally, this kind of sensors can be employed in areas where replacing batteries might not be economically possible or might pose serious threats to human life. Wireless charging of portable devices. So radio frequency energy is used everywhere. It is released by devices that produce strong electromagnetic fields such as cell phones, wireless radio networks, and TV transmissions. So the fact that ambient radio frequency energy is practically free energy is the main benefit. And chargeable electronics such as wearables, consumer electronics like headphones, e-book readers, and more can be powered by this radio frequency energy. So as a result, devices become mobile during charging and uses and are free of connectors, wires, and battery access panels. Additionally, radio frequency energy harvesting technologies enhances product design. So using this embedded wireless power technology, products can be walled off from external factors like dampness and user access. So both the product lifespan and reliability have considerably improved. Charging active RFID tags. So an antenna on the reader sends out radio frequency signal and the tag reacts by reflecting the energy. So unlike passive RFID tags, active RFID tags needs a battery to function. So when a battery is used to power these tags, the user is required to recharge or replace the battery. So the active tags can have a radio frequency energy harvester system attached to them so that they can use these radio frequency rays from the reader to power themselves without a battery. So applications of Internet of Things networks. An Internet of Things network's extensive device connectivity uses a lot of power. It is essential to provide enough energy so that the networks may run longer without losing the quality of service. The majority of Internet of Things network use cooperative relaying to transfer information between the network nodes. The source and the destination nodes interact through one or more intermediary nodes known as relay nodes when cooperative relaying is used. So better coverage and throughput are two benefits of this method. But however, as a result of the more relay nodes created, the network will consume more resources. One of the best ways to increase the battery life and energy efficiency in an IoT network is to use radio frequency energy harvesting technologies. Relay nodes that can send power from radio frequency signal in the environment are used in places of relay nodes that are powered by the network's battery. So the advantages and limitations of wireless energy harvesting. So under the advantages, the conventional power sources can be replaced. The unlimited spectrum of sources, efficient sources of energy. So it's a non-wastage, it's a completely green energy. No need for periodic replacement of the battery and extended life for devices due to recharging of storage battery during sleep mode. And the limitations of wireless energy harvesting. Radio frequency energy harvesting is limited by the amount of power that can be transmitted by the radio waves. The second limitation is that the efficiency of radio frequency energy harvesting is also limited by the distance between the transmitter and the receiver. So basically, further the distance, the less the power is received by the receiver. The third point is wireless energy harvesting has a lot of limitations due to its dependency on external sources, which are prone to atmospheric changes, physical obstacles, and radio wave source uptime. So the received power from these sources can be too low, and the level often varies in time. The fourth point is system efficiency is reduced over time due to the performance of the components used in devices like capacitors, diodes, backup storage, batteries, etc. The design of receivers in a wide frequency range is often challenging. A device designed to operate at one frequency band is limited only on that spectrum. So moving on to the conclusion. Simply said, radio frequency energy technology is a process invented in the 1950s to transfer radio frequency energy into DC voltage. An antenna, a matching impedance circuit, a rectifier circuit, and a storage unit make up a radio frequency harvesting system. Because it uses free radio frequency energy emitted by different sources including TV, Wi-Fi routers, and cell phone towers, this technology has become increasingly popular. Any effective systems must have stable, sustainable, and long-term energy sources. So future research will focus mainly on wireless energy harvesting to provide efficient solutions for fields such as IoT, medical, industrial, and other smart home applications as well. Thank you. That's it for the topic.
Arjun, am I audible?
Yes, you are.
So, good evening, everyone. As we are coming to the end of this section, I extend my heartfelt gratitude to today's speaker, Arjun Santhosh of SJCET, who enlightened us in detail about the harvesting radio frequency energy. I also want to express our appreciation to each one of his students for their active participation. Once again, on behalf of all the ECSA members, I would like to thank Arjun Santhosh for the wonderful section. If no one has any questions regarding today's section, please fill the participation and form in the chat box, or you can leave now. Thank you.